Everyone, it is Sridevi, Professor, Department of Electronics and Communication Engineering. In this module, we are going to learn about interference analysis in satellite communication. On completion of this module, the learners can able to understand the concept of interference analysis, which happens inside the satellite communication system. Before starting this module, the basic concepts about interference. So you have to know what is interference analysis in satellite communication system. Mainly, interference is known as the presence of unwanted signals on the radio frequency link, which produces the potential of interference degradations on the performance of the satellite network. The primary parameter involved in the evaluation of interference is power flux density, that is represented as PFD. So we have to consider one noise amplifier, and which is shown in the figure. This amplifier having the gain G and the noise power ratio PNO. This input is given as the input side, and with power G, and output is obtained from the output side. And the interference is simply noted as noise only. Input noise from antenna, that is input noise energy, is calculated as NO, that is equal to K into T antenna's temperature. And the different types of interference you have to know is natural phenomenon due to interference, and equipment failure interference, and ground electromagnetic environment interference, and adjacent satellite interference, and man-made interference. These are different types of interferences. So that is natural phenomena interferences due to some natural changes, and man-made interferences because of made interferences. The output noise of transmitter is transmitter side and receiver side should be calculated. Output is calculated at the receiver side. So output noise energy is NO, that is noted as NO, that is output is equal to GK. So TE is, if we consider TE is the equivalent input noise temperature of the amplifier, and total noise to the input is referred to the input amplifier, which is given as G equal to G1 into G2. So normally we know 24-hour orbit for satellite as communication. One such satellite would be within the line of sight nearly the Earth's surface at any given time. So properly, the aim of the satellite communication is the radio waves used for telecommunication links travel by the line of sight, and so they are obstructed by the curve of the Earth. The purpose of communication satellite is to relay the signal around the curve and the Earth, allowing the communication between the widely separated geographic points. So after calculating this interference, we can know the total antenna noise is equal to gain due to first amplifier G1 and gain due to second amplifier G2, and total if it is connected in cascade, it is taken as the NO at the outside. So in general, the interference analysis is which is in case of laboratory, it is also occurs in the non-target analysis or physical or chemical characteristics of sample prevented. Now the types of interference can be taken as simply it is because of physical noise and some convocations which is loudly made, etc. So then in case of satellite, the equipment faults such as uplink and downlink power control systems could cause the carrier to increase its power level so that it may cause the interference. So uplink of the satellite is the one in which each station is transmitting the signal and the satellite is receiving it. In other words, uplink in the transmission channel which carries the signal from the station on the earth to the communication satellite. The uplink CNR is referred as CNR is stand for carrier to noise ratio. CNR is equal to EIRP plus G by T minus losses, where the earth station is represented as array. The EIRP is earth station's EIRP, and G by T is the satellite receivers, and the losses, and these are considered, and the uplink parameters are calculated. Similarly, for downlink, this it is known as the satellite circuit in SIP1. The satellite is transmitting and the signal and the earth station is receiving, that is called as downlink. In other words, we can tell it is the path for communication of signals and the data from the communication from the satellite earth. So EARP of satellite is calculated and G by T of earth station is also calculated, and the bandwidth is known as C by N ratio, that is given as EARP minus losses plus G by T minus K minus V. This is all about base stations, and we have to know the quiz questions for the topic. So you have on the question like this: in a television, while transmitting in television transmission, it is an example for which type of transmission, that is simplex. Simplex means transmission is from one side. So hope this session is understood to you. Thank you.